Welcome back for part two of setting up the Verto steel flywheels. Hopefully you'll find this useful, and let's get into it. We need to start assembling the components. So the first thing you want to do with any new component is just check to make sure it's got no problems like pulled threads or in particular burrs. So run around the holes and see if there's any burrs on there. And most importantly on this side, because this is the side that mounts flat into here, any burrs here will mean that when that bolts into there, it won't sit flat. And if it goes cocked on sideways, for example, you'll have a problem with the you'll have a problem with the flywheel running around out of true, which is not good. So make sure that there are no burrs, and likewise around this area. Okay, all these threads, make sure they're not burred. Some of these are quite poor in manufacture and they've got very poorly applied chamfers and things like that. So this is one of the areas that I see a lot of flywheels when they come to me, that that boss is not mounted flat in there because people haven't taken time to make sure it goes in. Likewise around the inside of that hole there can also be burrs as well. Test fit to make sure that boss goes all the way in. Now on mine it does. I've checked it already, and you can tell I've already checked it because I've actually applied a mark, so I know when it goes in which way that goes in, so all the holes are lined. This only goes in one position where all the holes line up. One of the things people forget when they put these bosses in is they don't use the appropriate bolts. These must be a 10.9 grade, not the usual 8.8 grade bolt. Okay, so that's needed to ensure the appropriate clamping pressure is applied to the flange here, so it won't come loose in service. Now, if you use the 8.8 bolts, the chances are when you try and torque them up to about 42, 43 foot-pounds, you will strip the threads, or at least start to strip the threads. So be warned, use the appropriate grade bolt, which is on the head, should be on the head here. If you get bolts where the top has been machined, like this for example, where the manufacturer has supplied the bolt with the clutch kit, do not use it, purely because A, you can't see what the rating was, and B, this particular type that's in the UK is just the soft 8.8 grade bolt, which will result in pulled threads. So be very wary of bolts that are supplied with clutch kits. Okay, as long as only use it if it has actually got the 10.9 grading stamped on it. Failing that, sometimes the suppliers don't have these in stock, like mini spares for example. They supply these bolts and these are from them. You can also use these socket heads, the dome head ones, and as you can see, it's got the grading on it. So 10.9, that works perfectly well in here. I would just add a little bit of Loctite on there. You only need a medium strength, some of the blue colour, and that will work perfectly well. And these are actually financially a cheaper option, purely because they make millions of these, or billions of these all over the world. So these are a very good bolt for the money. Also make sure that the underside of the mounting holes on your pressure plate have got no burrs on, because again, if there's any burrs here and they get trapped between this face and the horn that it mounts on, then you are going to have a mismatch situation where it won't sit flat, and again the flywheel runs the risk of running around out of true. Before you assemble, make sure you degrease the friction face on the pressure plate, and I use thinners on a rag for this, and also the friction face on the flywheel. Right, clutch discs. New clutch discs sometimes have like a dressing agent or something on the friction disc from the manufacturer. I'm not sure why this is. Maybe it's to to help initial bedding or something like that. But in reality, this is like a sort of a greasy sort of substance which can actually reduce the measurement reading when you do this static torque test. So you want to clean that off. I just rub the face round with some 80 grit wet and dry paper, and then just wash off with brake cleaner, and then she's ready to install and test. Another bolt people often overlook is the bolts that go around and hold the flywheel pressure plate to the actual flywheel itself on these Vertos. Now, the original bolts, and here's one, as you can see on the head there, that is a 10.9 grade bolt. That's not particularly well marked, but it's on there, and that means again that that is a higher tensile than the normal 8.8. So it's very common for people, when they replace these bolts or they lose one, to put a standard bolt in, and that's not the right thing to be doing. These are a higher tensile for a reason, because you need the clamping force to hold that onto the flywheel. So these are hard to get hold of, or quite difficult. Well, in fact, the original ones are no longer available, as I understand it. So I change, as we can see here, to a 10.9 grade socket head, you know, a domed head one, as you can see here. These are M8 by 20, and they are perfect for the job. Again, if you want to, you can put a little bit of blue Loctite on there, just a medium strength thread locker, and once they're fitted for the final time, thread lock them in, and you won't have any problems. Okay, in order to test your flywheel, you need to put it together, put the friction disc in the middle, and I use my torque wrench driving adapter to center the unit. So I put it all together with that in place that centers the friction disc. The dowels that we took out earlier are still not in at this point because they're not actually needed. The 6 bolts on the outside are enough to center this for the purposes of doing our torque testing. That also means that we don't have to, because we don't have to put the dowels in, it means if we need to adjust the horn heights, we can do simply by just putting it back on the lathe and machining as necessary. Torque testing is achieved by using a torque wrench into the flywheel, and I always turn it in the direction of the way the engine would rotate. So effectively the flywheel goes in this direction, so you pull the torque wrench downwards. Okay, so torque testing is simple. We just apply the torque wrench and we keep increasing the torque till we find the point it slips. Right, that's slipping, and then we come back to it. And sometimes to hone in on it, you have to do a couple of goes. This is not, you know, it's not a precise science. You have to, if it slips, it will tend to keep slipping. So you have to stop, reset and try again. And also it can slip as it just goes over the setting. So kind of take an average. So you're doing a number, you can see it's almost on the verge there. Right, that's 132 foot-pounds. It's just virtually right. A little bit of slippage there. Okay, so that one has come in. I don't know if you can see that, but that's 129 foot-pounds. Now the previous one I tried before this was 127. So they're fairly consistent. Okay, one of the things to look for on a Verto clutch is to see the diaphragm spring. I'll just get that in focus. There we go. It shouldn't be flat when you're looking for maximum clamping force. All right, so that's about the position you want it. If you, when you measure your torque setting and it gives you a figure, if that's not high enough, you need to look at the angle of this. Okay, if it's flat, you know that you need to increase the horn height. All right, and if it's past flat and bending out of that angle, you've got to massively increase the horn height. So my suggestion is to use this little process which I use to find the optimum position. So how do you work out how much to take off the horns? Well, it's actually quite simple. In terms of the Verto flywheel, as I've just shown, that's the diaphragm in the position for the maximum strength. Now what you need to do is to put it in the vise, and then you need to incrementally increase the horn height. Now that's easy. Simply, you've got these 6 bolts around the outside. One turn of those bolts, being a 1.25mm pitch, or about 50 thou per revolution. So what I do is I mark the bolt and I back it off a quarter of a turn, and then I know that's about 12.5 thou. So if I do that all the way around, and then with it in the vise, I torque test it, okay? And I see if that increases the torque. If the torque has increased, I'll go another quarter of a turn back out, and then I torque test again. And then I find the point of where I've reached almost, okay, the maximum. Okay, and that range normally lies somewhere within 0.9 to 0.945 thousandths of an inch on the horn height. Okay, the reason why you don't go all the way to the maximum point is, as the clutch wears, the friction disc gets thinner, and effectively you will lose clamping force. So if you go up to the point where you're getting almost to maximum friction or maximum grip, and come just below that. So typically on this flywheel with this cover and this friction disc, I use 938, 939, 940. As I say, you saw me in the video earlier, in part 1, I've machined these to 939. These have worked out perfectly. In the case where some clutches and some friction discs, they do vary. So the friction discs, particularly in thickness, so you can't just swap the bits or see what you've done in this, see what I've done in this video and apply that to another clutch. Doesn't work. What you have to do is you have to assemble your clutch, and you have to go through this process of working out where that diaphragm is. All right, by backing those off and measuring the torque. Now, some applications require that the horn height is lower than what your new flywheel is. Now in those cases, what you need to do, and what I do, is I have a surrogate flywheel with the horns that are machined down to below 900 thou, and then I build the clutch, and then I can back the screws out, and it gives me the full range of adjustment. So I know that's not suitable for all, but I'm trying to explain to you that sometimes you can't do this at home without having the appropriate equipment, or having somebody that can do it for you. So I'm just showing you how I do mine. There are no doubt other ways that other people do theirs, but this is what you get when you buy an AC Dodd clutch. Once you've determined what horn height you need by using the backing out the screw method, you then need to strip the unit back down and put the flywheel back in the lathe, and then machine the horns to give you the height that you just worked out. Time to refit the dowels. Now the dowels that I use, you can either make them out of silver steel, or you can use a proprietary aftermarket one. Here's one that I prefer to use, which is a threaded dowel. So the original factory ones were either mild steel or hardened. So I use a case hardened dowel, same size, but it's got an M4 thread. And the idea is that once you install that and drive that in, you can actually extract it again at a future date if you need to do any more machining to the horns or the friction face, and you need to, you know, use it or set it up for another clutch. So this enables you to do that. Something to look out for from suppliers is most of them don't put an extractable dowel in, and I think they're missing a trick here. There we go, dowel installed. Second dowel installed. If you do get a loose dowel, it's okay to Loctite these in if you need to, but if they're very loose, then I suggest you need a custom oversized dowel to make good that repair. But these particular dowels I find are the best solution for these flywheels. Anyway, with that in mind, that's the end of the video. We now just need to assemble that and get it ready for balancing. There's already a video on balancing, so I won't cover that in this video. Anyway, I hope you guys found that really useful. As ever, if you want to see more, please like and subscribe. Thank you very much.